My background is as a psychologist, a clinical psychologist, and school and educational psychologist. And I'm maybe in some terms a late bloomer because I did my PhD as a part-time study. So I finished my studies in 2016 at the Mid-Sweden University. And my field of interest is a number of quite fuzzy concepts in some aspects. I mean, metacognition is something that I'm very interested in, but when you delve deeper into metacognition, you realize that this is a concept that is defined in many different ways and applied in many different fields, from clinical therapy, a new wave of cognitive therapies focus on metacognition. And on the other hand, in educational settings, metacognition is quite big in some fields. And in Sweden, metacognition is something that teachers are very interested in metacognition. So this is one of my areas of expertise, if I may say. And I'm also interested in understanding executive functioning through the lens of metacognition. And executive functioning is also a concept that might mean different, might have different definitions of these things. So I've called my presentation here, and I mean, my presentation is actually, the title is kind of a clickbait, because it could cover everything here if you consider it. I mean, but I'm going to start in the neurocognitive area and the neurocognitive processing perspectives. But as a clinical psychologist, but also a researcher, it has always been important for me to try to link these neurocognitive processes to curriculum content, to try to understand what happens when children meet the curriculum content, or the knowledge, the different types of knowledge. And also try to understand what happens when a teacher designs a certain instructional situation where the ambition is to teach some kind of knowledge or curriculum content. So because teachers work differently, and some of you might be teachers who are attending this, instructional design is a whole area to reflect on. Does it matter how children's neurocognitive processing abilities are formed for the instructional design? Well, it's a leading question. I would say yes, it does. And also we can broaden the perspective and talk about learning environments in school as a whole, the physical environments. Does it matter how we design physical environments for the children's neurocognitive processing abilities? And I would say, of course, yes to that as well. So what is the challenge? Well, the challenge is that when I have tried, and my fellow researchers at Mid-Sweden University and around Sweden, when we are thinking of conducting research, it's a challenge to design studies in the complex environment of the school, because you have so much noise in school. You might work with efficacy studies and try to be very strict with the intervention study, and you're trying to define the concepts very clearly, and you're trying to control the intervention. But I mean, if you've been in a school for a while and watched the processes, you know that when we try to make intervention studies, there is a lot of noise, and that moves us into the other type of intervention studies, the effectiveness studies, where we are trying to understand what we initially thought we wanted to study, efficacy studies about metacognition, for example. When you move metacognition as a concept into a classroom or into a small group of intervention, there is a lot of noise in implementation of this study, and teachers have, in our research projects, they want to adapt the intervention to their circumstances. But from a treatment fidelity perspective, it's difficult because you have a threat to internal validity. So your concepts that you might have thought of at the department when you sat there designing this study, you had a pretty clear idea of how to have internal validity in your concepts and interventions. But when you move it out, you have the external validity. And there's a lot of noise and threats to external validity, and so this is a challenge from a research perspective, to both consider internal validity and external validity. And I was part of gave a presentation at the Excellent Early Conference that was hosted by Joe and colleagues at the UCL, and we have a study now where we are looking at the neurocognitive abilities in the school system, and we can still see in our research, this is preliminary results, but we know that kids in the Swedish school system, kids with and without special educational needs, and I mean we have a 3-level system or a 3-tier system in Sweden. We have general education and differentiated instruction in the regular classroom at level 1, and level 2 we have special adaptations that special education teachers and other professionals provide near the classroom or inside the classroom, and then we have a outside classroom support. And we have seen in our research, when we are looking, for example, at executive functions, we see that executive functions play an important role. There are significant differences between kids at these three levels of the support system. So I'll come back to that, and I'll come back to a definition of neurocognitive processing abilities. But we can see that clearly children have different prerequisites for learning, and over time in the Swedish school system, in the primary and secondary school, children are referred to these 3 levels or these 2 levels of support, the 2nd and 3rd level, and neurocognitive abilities plays a role in that selection, so to say. And I also want to I would like to move into the classroom for a moment, just to give you my framework and my colleagues' framework about what we want to do with our research, because we often, when we talk about neurocognitive processes or neurocognitive functions or abilities, we talk about them separated from the school situation. We know that for example, that working memory plays a role in early maths development, etc. But we want to link the neurocognitive processes more clearly and with a more fine-grained resolution into the educational situation. We have used this three-level definition of what we want to look at in our future research. And in the center is the curriculum content. I think that we should talk much more about how curriculum is constructed in different countries and what teachers, what kind of knowledge types are found inside the curriculum content, and we can have different models for talking about knowledge. How do we understand fuzzy concept of knowledge. We might use the taxonomy of Bloom, which has influenced the design of curriculum in many countries. And we can look at language and maths and STEM subjects and so on. But the point here is that neurocognitive processes are like realized in the curriculum content. I prefer to make a quite close reading of curriculum documents in school. I've spent a lot of hours reading the goals in the Swedish curriculum for primary school, for example, and looking at the knowledge types that teachers try to teach kids and that they use as evaluation also when they put grades on kids. And I'm trying to see what kind of neurocognitive processes are embedded into the curriculum content. And this is a criticism against me and my colleagues, actually, a self-criticism. We often settle for quite, I mean, we use often quite advanced neurocognitive measures, and I mean we have fantastic neuroscientific methods to measure activities, brain activities in different ways. But when it comes to the outcome variables in our research, we often settle for measures like maths, for example, standardized math measures that are not so fine-grained and not always clearly connected to the curriculum content. So, I mean, this sounds like a general criticism. This is not the case in all aspects, but still we can see that I would like to see more of studies of the link between neurocognitive processes and different aspects of curriculum content, because that way it also becomes meaningful for teachers to understand how a specific area in the curriculum content or knowledge is affected by neurocognitive processes. So this is something about finding not only fine-grained and high-resolution neurocognitive measures, but also increase the resolution of what we are looking in the educational system or area. So you see, the center is about the first factor or variable or area to explore more. I think that we need to explore more of a curriculum content. And the second area that we need to explore is how teachers design tasks in learning, because you can work with the same knowledge content, but you can design tasks in different ways. You can work with collaborative learning, or you can work with individually or whatever. And then we have the learning environment as a third area. How do the physical design of the learning environment affect kids? So I'm basically interested in understanding how curriculum and teaching and learning, how we can understand that, and what kind of neurocognitive processes that we should look at in relation to learning. So, and one study that we have where we have explored some of the neurocognitive abilities is a recently published study this summer about the relationship between fluid reasoning, working memory, and planning. And I'm highlighting planning here because this is one of my main areas in research, the neurocognitive process of planning. And we might think that planning is something, activity in the classroom, and it is an activity in the classroom. Teachers plan and kids plan, but planning is also a complex executive function. It's one of those important executive functions that is about organizing you and creating a plan for your actions in learning. So we showed in those studies that when we talk about assessment of risk for mathematical difficulties in the Swedish school, we found that the frontal lobe executive function of planning ability predicted risk for mathematical difficulties above fluid reasoning and working memory. And in my opinion, planning has been overlooked or not ignored, but we have missed to reflect on the role of a planning ability. And there is a great deal of research about children's early planning development that plays an important role. So in our studies, we have defined neurocognitive abilities as, I mean, it's self-evident, but we see them as dynamic brain-based processes involved in thinking, problem solving, and self-regulation of emotions and cognitions and behavior. And particularly in my research, I'm interested in something called the PAS theory of neurocognitive processes. So that gives you an idea of the tradition that I'm rooted in, and it is rooted in the neuropsychology of Alexander Luria, who's a prominent researcher in the field of executive functions, for example. And with the starting point from the PAS theory, and that is well researched since 50 years back, I would say, we try to understand how does the PAS processes, or these 4 neurocognitive processes that are involved in the PAS theory, how do they affect, and what's the interaction between them and different areas of learning. And I'm not going to give you a full lecture on the PAS theory. You can read more about it, but simply you could say that the PAS theory is about planning processes, and you see that planning processes are related to metacognition and self-regulation and thinking about thinking, which is a nice connection with many curriculums in different countries that stress the ability for children to learn strategies about how to learn. And we have classical attention concept about attention shifting, persistent distractions. And then we have 2 processes that are not so common in other models of neurocognitive functioning. The first one is similar to the fluid reasoning processing, which is about understanding relational reasoning and part-whole relationships and pattern recognition, visuospatial thinking, etc. And the other process, both these processes, simultaneous and successive processes, they are about encoding, storing, and retrieving knowledge from memory. So they are related to long-term memory and retrieval from long-term memory. So there are meta-analytic reviews. I'll send this presentation so you can look up this, but there is a lot of research about different areas like reading and writing and maths, and a nice meta-analytic review by Giorgio and colleagues that also was published this year. And I just want to say something to show a nice connection, because in Sweden, something that is trending very much in schools is reflecting on how to design learning. And universal design for learning is something that is really, people are interested in Sweden. Teachers are interested in how to design the lessons and the learning environments. And actually, from the Luria and the PAS theory, there is a nice overlap from the PAS processes to the brain-based model that is used in universal design for learning, which the goal of universal design is to improve inclusion for kids with variation of functioning and kids with special educational needs. And it's also about making learning accessible in the regular classroom at level 1 in the 3-tier model. We saw in a study that we are in preparation, we saw that particularly planning is challenged among kids with special educational needs. So what does this mean in the extension? It means that we we have to help teachers to find ways to understand the variation of children's neurocognitive processes, and particularly the role of planning is something that is I think that teachers have to think about. How do we help kids to plan their actions and their learning? And this goes down to how they work with schedules in the classroom, or the lesson structure, or whatever. In the design of the learning, you have to, as a teacher, and particularly in the area of mathematics, for example, mathematics is a very planning heavy subject, and there are like studies from OECD and the people behind the PISA program that shows that mathematics has become more and more planning and problem solving intensive. So this is something that we have been interested in. So we can see that the role of executive functions like planning and attention, as well as the role of those two other past processes, simultaneous and successive processes, we can see that we have a clear evidence base to find the connections to maths and reading and writing and language development and so on. But I'll move into the question about intervention, because we have also conducted some intervention studies, particularly addressing the planning ability and just as a background to the challenge of working with planning and metacognition as an intervention. You have a early definition of metacognition here. I mean, we can talk about metacognition as thinking about thinking, but that's quite fuzzy. I mean, what does that mean? Thinking about thinking. Everything might be metacognition. But I think that Vygotsky actually, this Russian psychologist, actually, together with Luria, they defined metacognition with this. I find this citation intriguing. I still have to think about what is said in this citation, but it gathers the challenge also when we are talking about frontal lobe functions and awareness. I mean, how do kids regulate their thinking, and how do we nudge them into becoming aware in their learning? And because if we want kids to use strategies and replace bad strategies and replace unconscious strategies to more deliberate and intentional good strategies, we need to work with kind of help kids to wake up, to become aware about what they are doing, when they are doing, and in what way they are doing. And this has actually been what we've been working with when we have been designing the interventions in our studies. And I'll show you quite concretely how we define the metacognitive intervention or a planning intervention. I might use metacognition and planning at the same time, because they are so interrelated, and in the past theory they are practically part of the same concept. Metacognitive planning. We can also talk about metacognitive self-regulation. There are many names for these kind of phenomena, but I think that you understand the point here is that we want to awake and make kids aware of and help kids monitor their actions and hand over good strategies, because kids do well if they can and if we give them tools to do well. But kids, that's my experience as a school psychologist also, that when kids don't do well, they seldom do it because they want to make harm deliberately, but they do bad things or end up in bad situations because they don't have good strategies. So we need to help kids develop good strategies. So this points also to the area of strategy training, and at the early conference in August, I had the opportunity to listen to one of the keynote speakers, Maria Chara Pasolungi, who talked about her maths research and working memory, and I was encouraged by her talking about the need of thinking about metacognitive strategies as part of how we can help kids develop their maths abilities, but also how we can help them to develop their executive functions. So what did we do? This study published 2016, we did it was a pilot study. We recruited 66 children with special education needs, and we narrowed it down to ages 8 and 9 year olds from 10 primary schools in Sweden. And we randomized these kids into 3 groups, 1 control group and 2 training groups. And then we conducted 1 pure working memory training, and it was the Cogmed training that has been developed in Sweden, and that is also well researched. And then so 1 intervention group got working memory training, pure working memory training, 5 days a week in 25 sessions. And then we had a working memory plus metacognitive strategy training group. And that was a group that 3 times a week got 20 to 30 minutes of metacognitive strategy training. And I'll define and show you how we define the metacognitive strategy training. I mean, I'm always self-critical. In the best of both this research worlds, we would have had some kind of placebo or double blind or whatever, but it's difficult also to find perfect design. So there's a lot of improvement in this design, but still we got some really interesting results. So after 5 weeks, we did pre-post and 6-month follow-up tests on a number of cognitive measures. And then we followed up them also on reading, writing, and arithmetics. And actually, similarly to most working memory training research, we found no long-term effects on reading, writing, or arithmetics, so no far transfer, but we found near transfer. And this is, if I generalize a little bit, what also a number of meta-analyses have showed. And I've been thinking a lot about how we should design working memory training and maybe how we should not design working memory training. But there was still very interesting results from the metacognitive addition, because we found effects on visuospatial working memory on post and follow-up testing only in the metacognitive strategy training group, while the regular working memory group, the results decreased on follow-up. So we got quite high, strong effects on following the metacognitive strategy group. So how did we design the metacognitive strategy training? The structure was, it was a semi-structured teacher-led session, and it was 20 to 30 minutes. And it was a small group. We had a cooperative framework. So we wanted to use a framework that and a setting that is familiar for teachers. I mean, working small groups and cooperative frameworks. So kids, 3 to 5 kids together with a teacher had these semi-structured teacher-led sessions. So teachers got an initial theoretical introduction to the area of metacognition, and then some general rules about how to structure the sessions, and also some general rules about working with an inquiry-based method, not teaching kids how they should do, but activating their reflection. And this is something that, at least for Swedish teachers, is something that is very familiar way of working as a teacher. And all sessions started with a concrete exercise, a snapshot from the working memory exercise. So the kids had the opportunity to analyze the working memory training and reflect on the different exercises, because the regular, at least at that time, this is a number of years, the working memory training programs, they change their formats. But at that time, the working memory training of Cogmed was simply a time on task training. It was not so much about reflecting on strategies and how to be successful or not in the working memory training. It was more of a brain gym. Kids train increasing working memory load during the computer program exercises. And we added these exercise metacognitive training, where kids could reflect on and think about what is happening during the working memory trainings, and what strategies could be fruitful, and also what strategies might not be so fruitful. So we had five phases in the semi-structure that the teachers followed, but they were always asked to follow also the associations of kids to balance it. So if kids, for example, started talking about what is the goal of working memory training, the teacher followed that association. But in the end, we made sure that the teachers still worked primarily following this semi-structure. The first area was working with labeling objects, terms and concepts in the working memory. So, and this is a hypothesis that language processing, while in early phases of learning what things are named and so on, this might increase cognitive load in kids when they are trying to remember what things are called and so on. But the idea was that after a while, kids will be more familiar with what is happening, what the things are called in the working memory training and the terms and concepts. So it's more easy to have a relational thinking about what strategy am I going to use now when there is a rotating object, for example, in the working memory training. So and then the second phase in the metacognitive strategy training was to formulate the goal. What is the goal here in the working memory training and the specific exercise? And then we had two types of strategies that they reflected on cognitive strategies, which are more like related to the situation. What is the best way of being successful in this exercise, which is about metacognitive knowledge. And the second type of reflection is about metacognitive strategies, which is more about how are you going to regulate yourself to be successful. And then a final phase in the reflection was reflection on transfer. What did you learn today? Can you see any connections to learning in school? The idea is to help kids to understand how to transfer their knowledge into classroom situations or everyday life situations. And teachers took also, they wrote protocols like semi-structured protocols, and we haven't published, but we discussed afterwards in the evaluation, and kids showed a remarkable development. This is anecdotal because we haven't published that part, but still they showed remarkable increase in ability to reflect on strategies and use strategies. So that was very encouraging. So what we wanted to do with this study was like to leave a static view on working memory, that working memory is something that you train just like a muscle, and instead try to understand how working memory is related to awareness and metacognition and planning ability. And this is actually, I was very encouraged when I saw a study for a while ago, Swedish researchers who talked about this, also leaving the traditional Baddeley model of working memory and having a more dynamic perspective on working memory, that it's not a single ability, it's not even a dual process, it's a number of combination of neurocognitive processes that interact as a dynamic system. So what do we want to do? And you see attentional processing as part of working memory, the neurocognitive architecture of working memory. We wanted to activate the frontal lobe aspects of working memory, because working memory is not a place in the brain, it's a process, and it's about attention control, it's about monitoring yourself, it's about thinking about your thinking. And actually that also I saw another paper for a number of years ago that exactly connected this, that when we look at working memory performance, it fluctuates dramatically between items during working memory testing. And they this proposes that this what is happening when for example, when kids have low working memory, there is like metacognitive blind spots during their processing. And this makes sense. It's another way of describing this is talking about a loss of attentional control. So it works perfectly well with the working memory theory of attention control. But I really like the idea. I was captured by the idea that because it's something very concrete that you can understand, that kids lose their conscious awareness for a moment during working memory processing. So our idea is instead to, can we increase awareness? Can we, via metacognitive interventions, help kids to increase their awareness and regulation of their metacognition and attention? So, I mean, our study is not an efficacy study of, and not a strict study of these processes. That's more of an experimental and laboratory study. But this is still interesting to think about. How can we see that we improve working memory and executive function via a metacognitive and a planning intervention instead? So individuals fluctuate in their metacognitive awareness and monitoring during working memory functioning. And we can see that in testing situations also. And there are researchers at Cambridge University that have not replicated, but they have developed the metacognitive strategy training in a very nice double-blind randomized control trial. And they have also they had some really interesting effects on the functioning of kids. So I recommend this article. I was very inspired by it. And then just the other day here, there was also a study of kids with ASD, autism spectrum disorders, where they did a pilot study on attention and executive functioning training, cognitive intervention. And they also used a metacognitive strategy training. So it was a small study of 20 children, but they saw that with the help of this intervention, the error of kids in attention, the error rates decreased potentially as an effect of the cognitive training. So I think that this is a very interesting area of and a slightly different area about how to work with cognitive training. And I'll skip some parts here. I could talk the whole evening, but one of my final thoughts is that it beats me. I'm still puzzled, and it's for my own, I'm self-critical here also, while we still try to find cognitive training regimes that are separated from knowledge content or naturalistic situations in school. We should much more work with understanding working memory in the learning content and training strategies that are quite easily applicable in the classroom and in the naturalistic setting of school also. And also when I look at studies, I'm also puzzled by why we don't measure more of curriculum content in our learning. This is something that we intend to do, and we want to create metacognitive strategy training procedures that are connected to curriculum content. We don't want to go via cognitive training and then to classroom for finding for transfer. Let's go directly into the curriculum content instead. This doesn't outrule the idea that there might be some general cognitive training that might be effective in the future, but I think that this would be an area of trying to understand and improving children's neurocognitive processing in learning instead. So I think that I will stop there and open up for questions, and also don't hesitate to contact me if you have any questions that might arise after this session. So thank you very much, and I'll give back the word to Joe. I'll stop sharing also, I think.
Thank you, Petri, for your talk. Very interesting. Yes, so we've got, if you want to ask any questions, please put them in the chat box. There will also be a way for us to see whether the chat box actually works today. So I don't know whether you have any questions. I do have a question. I mean, I've got a number of questions because I'm very interested in this area myself. But one of the things I want to clarify is when you did your training, was that content free, or was it the teachers who set the content, or did you set the content of the activities? I mean, obviously you had the content of the metacognition, but
yeah. Well, the content was the working memory training, because we wanted to see can we affect the success in working memory training. So actually also our hypothesis was that this might increase the far transfer to because we had the idea back 2016 already, and before we did the training earlier, that there are problems with transfer from working memory training. So we wanted to see if using metacognitive strategy training will increase the success rate in the working memory training. And actually we reported data also in my thesis, reported data that the kids who participated in the MST setting, they had higher scores in the working memory training because the working memory training CogMed also gives a score inside the program, and teachers reported that kids were very motivated also. So I mean, there are a lot of fuzzy effects going on here with an increased motivation also with the metacognitive strategy, but because these kids got the opportunity to reflect upon the working memory training, while my general experience from working memory training with kids, the regular CogMed, is that kids after 3 weeks, they are getting bored of the computer program. So, but anyways, we didn't see transfer. So that's the case.
A question from Iraz here. Iraz had a look at a paper, and it seems that the planning measure included things like the trail making test, which is considered more of a switching task. And so the question is like, how would you define planning in terms of, your pre and post measures, and how that probably links to what you were training? I don't know whether you want to...
I can comment that. Actually, in the metacognitive strategy training, we didn't measure planning. It was the other paper that I described about assessing risk from maths difficulties. But actually, I would say that trail making test, it has a component of switching, but if you look at the construct, constructs, and if you look, I've done exploratory factor analysis and confirmatory factor analysis, and I would say that it doesn't primarily measure switching. It loads on planning to a higher degree than on attention and shifting. There is, I mean, these processes are intertwined. I mean, they are. The brain is a network and a system, and it's difficult to smaller kids, younger kids. You see, developmentally, planning and attention is not divided. It's like more of a one function. If you look at the factor structure. But we looked at the factor structure both for kids with SEN and the factor structure on normal population. And the factor structure shows that trail making test is a complex executive function, while shifting is a simple executive function. So there is overlap, but actually, and if you look at the theory behind trail making test, it is originally in the history, it was a measure of planning. So I would say that it's more planning than pure attention, according to the shifting theory.
So we've got another question from Jane Cohen, and thank you for explaining that, Petri. You know, it kind of goes back to when you were saying, like, you know, can you ever make a test that is completely about planning, you know, because maybe planning is in every test, but that's another question. I want to go back to Jamie's question, which is, can you give a bit more detail on how the children were taught specific strategies to use? Were they subject to visual representations of learning that helps them effectively?
Well, actually, the only visual stimuli that was presented was the starting point of one. Cognitive is a number of exercises with different focus, and we used a visual stimuli from the starting picture on each exercise. So they looked, for example, on one exercise is visual rotation, visual spatial rotation exercise. So they looked at the stimuli, and then they reflect. The rest of the reflection was actually verbal in a small group, but it was allowed to draw pictures and so on. But we didn't. The teachers were always asked to try to induce reflections from the kids about strategies. So we didn't have an explicit training, this way you should do it, or you could do it like this, but we simply wanted to activate the kids' awareness of strategies. So there was no like Bible about how you should, no manual about how you should, what strategies. Teachers never explicitly taught the kids predetermined or pre-designed strategies. And I mean, that's interesting. I think that you could do that, and I think that you can maybe increase the effect if you also have a number of strategies that you teach. But this was like a pilot study, so I think that you could have a manual for if the kids don't themselves. But often they had good ideas. We see it in the protocols from the log books from the teachers, that many kids had fantastic reflections about how to concentrate and how to do the best way, for example, to prepare for attentional awareness or being concentrated. But I think that's an area to develop, absolutely.
Well, it's indeed interesting that you find these effects even though you don't have a very specific intervention. So yeah, you might not know the mechanism behind it, but it's still impressive that you found these effects, and it shows that you could indeed have got higher effects there. And
Absolutely.
Victoria had a question on the transfer and application, what it entails, whether it's a particular subject. And I think it was similar to my question, but maybe it's not. So I don't know if Victoria could elaborate a little bit on her question. And in the meantime, you know, you also mentioned something very interesting at the beginning, which was like, you know, what we should not do in working memory training. And I was wondering whether you could, you know, we have a few minutes, whether you can elaborate on, you know, what not to do.
Oh my goodness. Well, I would say that this is about the perspective on working memory, because I think sometimes that we look too static. We see it as a static ability, like something that is in Sweden. When I talk with teachers, they sometimes think that working memory is like a number of slots in your brain, and some people have 7 slots in their brain and some have 5 slots. And if you have low working memory, then you have only 2 slots, bad luck. And then we should train your brain in a gym so you get more slots. It leads somewhere else in the working memory training. It like makes working memory static thing rather than a process. And I like the dynamic processing perspective on working memory. I don't want to accuse working memory researchers to have a static view, but the application out among teachers is like, oh, it's like intelligence. Oh, the kid has low working memory, so it's a disability. I try to talk about, let's talk about what working memory is what kind of processes are involved in working memory, and what happens when you improve, for example, metacognitive awareness and give them kids strategies, when then working memory expands or has the potential to change. So what should we not do? We should not train working memory too much as a static property, separated from, this was the 3-circle model, separated from curriculum, content, task design, and learning environments. Instead, talk about working memory processing inside curriculum, tasks, knowledge content, and learning environments.
That's really cool. So we have another question here. I was wondering if metacognition training could be detrimental, say metacognition leading to increased anxiety. I think that's a fantastic question.
That's a great question. And actually, this is, I'm part of the board of the scientific advisors in Sweden for the Swedish Psychological Association. And we have revised our evidence-based guidelines for psychologists. And we are having a lot of discussion about psychological interventions might also be detrimental. We don't talk so often about risks and detrimental effects. I would say absolutely there might be detrimental effects, because this way of working increases also cognitive load. You increase the cognitive load, and I think that you have to be like, as a teacher, you have to think about when you work with metacognitive reflections, you have to adapt that to the children's level of functioning. If you ask children to reflect on strategies, but they don't have basic knowledge of what you're reflecting upon, we can assume that this kind of strategy reflection, where we don't model and where we don't explicitly teach kids strategies, could be detrimental and increase anxiety. So I think it's a really good question, and we should much more think about these things.
That's great. Yeah, I agree entirely. We've got one more here. Sorry, I was listening to you, so I wasn't reading the question. So you mentioned developing metacognitive procedures for particular areas of curriculum content. Do you have any specific part of the curriculum that you feel this would be most effective?
Absolutely, and I'll take the easy way out here, because it's about maths, of course, one of my favorite areas of inquiry. So I would say that look at do a thorough reading of the knowledge content in maths in different ages, the school curriculum, and look with metacognitive eyes, and you are going to find parts in problem solving. In Sweden, we have teachers, when they put grades, there is a lot of demands that children can make self-evaluation. Especially in the secondary school, kids have to develop the ability to do self-evaluation. That's part of the grading. So if you're not good at self-evaluating, which is about metacognition, thinking about how was I successful? What should I think about next time I'm learning this area, working with this area? This is definitely an area where metacognition plays a role. And I see a question also, what about science? Definitely the STEM. I mean, maths and the STEM subjects there is so much. I looked at chemistry in the Swedish school. I looked at a lesson about a laboratory lesson in chemistry in grade 8, and I discussed with teachers when we have talked about metacognition and the PAS theory and processes. We're having a reflection together about, can you see kids who have better underlying processing abilities to conduct this chemistry procedure, because it's a procedure. You have to do this chemistry lesson, elaboration, you have to know the goal, you have to self-regulate yourself through the laboratory experiment. So in the STEM subjects as well. But I have preliminary results. So I even in reading, writing, and in Swedish language, we see that the past processes explain about 15 to 20% of the performance during national curriculum tests. This is preliminary results, so not published, but we are writing a paper about this. So if you thought that national curriculum tests of knowledge in your countries only test what children have learned, we are wrong. We are testing also their underlying cognitive abilities, because they play a role in how children perform during national curriculum tests in different subjects.
Well, Petri, on that note, thank you very much today for your talk and your insights. It's been, very interesting. I'm sure everybody agrees with that. Thank you all for those of you who've attended today. We'll be back next week with a talk. So do join us again next week at 4 o'clock. Thank you all very much. See you soon.
Thanks.
Thanks. Bye.